I'm going to graph the cosine graph. Cosine goes here, here, just like that. And it takes 2 pi to graph a full period of cosine. And this is pi over 2, pi, and 3 pi over 2. This is your cosine graph. And of course, it continues on forever in both directions, correct? All right, so we're going to be talking about the inverse of cosine. However, as it is, cosine does not pass the horizontal line test. It crosses, when I draw a horizontal line, it crosses multiple times. It crosses more than once. If a function fails the horizontal line test, that means it's not invertible. That means you can't find the inverse. So what I'm going to do in order to find the inverse of cosine, I'm going to have to restrict the domain. I'm going to cut it off here and here. And I'm going to ignore the rest of the graph. I'm going to scribble that part out. I'm only going to pay attention to cosine between 0 and pi. That way, when I do the horizontal line test, it passes. I can draw many horizontal lines and it only crosses once. So if I only look at cosine between 0 and pi, I can find its inverse. We call the inverse arc cosine. You'll see it written like this, and you'll also see it written like this. These both mean the same exact thing. That is the inverse of cosine. Okay, so let's make a table for cosine. Cosine at 0 is 1. Cosine at pi over 2 is 0. And cosine at pi is -1. So if I want to find the inverse of cosine, this is also called arc cosine of x. These mean the same exact thing. If I want to find the inverse of cosine, all you have to do is switch the x's and y's. So that means these will be 1, 0, and -1. This will be 0, pi over 2, and pi. So not only do you switch the x and y values, you also switch the domain and range. So guys, notice over here, when I restricted the domain, I was only looking between 0 and pi, right? I restricted the domain. That means that's my new range over here. And over here, my range was from -1 to 1. So the range here was -1 to 1. That means that's my new domain over here. So let's go ahead and graph it. So if I graph my arc cosine graph, I'm going to spread it out a little bit. I'll call this -1 and this 1. I'll say up here is pi over 2, and I'll say down here is -pi over 2. Okay, so 1, 0 is right here. 0 pi over 2 is right here. And -1 pi is up here because this is pi. All right, so this is what my graph looks like. Here it looks like a straight line, but it does have a little wave to it, depending on how wide apart you make your points. Okay, so we have to memorize this. This is the domain and range for arc cosine. Guys, we restricted the domain of cosine, okay? So we only look between 0 and pi. That means on your unit circle, you're only looking between here at 0 and here between pi. That means your arc cosine, also known as the inverse of cosine, is only in the first quadrant and in the second quadrant. That's the only place you should be looking when you're doing the inverse of cosine. You're not looking down here ever. because we restricted the domain. We're only looking between 0 and pi because that is where it's 1 to 1. It passes a horizontal line test there. Okay, so this is your important slide. Today we're focusing on cosine, the inverse of cosine. We'll do these days, or we'll do these notes on a later day. So your domain, we said, was -1 to 1, and your range is 0 to pi. And you only exist here and here. This is where you're going to find your cosine inverse, the inverse of cosine. We're only looking in quadrants 1 and 2. You will not give me things down here. Okay, so let's try this problem. If you think about a unit circle, 7 pi over 4 is right here. Do you guys know the coordinate of 7 pi over 4? Exactly. Square root of 2 over 2 and negative square root of 2 over 2. So if I want cosine at this location, that's going to be right here, square root of 2 over 2. So that means I can write this problem as cosine inverse of square root of 2 over 2. Now, how do we solve this? You need to ask yourself the question, where is cosine equal to square root of 2 over 2? Where? And remember, hold on. Remember, you can only look at this notes, look at these notes. You can only look in this quadrant or this quadrant. You should not be giving me any answers down here. Yes, it's in quadrant 1, right here at pi over 4. The coordinate here is square root of 2 over 2, square root of 2 over 2. So that is where cosine is equal to square root of 2 over 2. So the answer to this is pi over 4. If you told me 7 pi over 4, that would be incorrect. Even though cosine is equal to square root of 2 over 2, the inverse does not exist down here. Okay, so it has to be this one. Okay, now try this problem. Okay, so let's try this one together. We start on the inside, so we're looking at 4 pi over 3. That is right here. This is where 4 pi over 3 is. Can you guys tell me the coordinate right here? -1/2 and exactly, negative square root of 3 over 2. So this is the sine value. So that means I can write this as cosine inverse of negative square root of 3 over 2. That's what this is. Okay? So now you need to think about, this is a question that you're asking. Where is cosine equal to negative square root of 3 over 2? That would be on this side over here, right? This is the long distance. This is the short distance. So this is 1/2 for y, but this is square root of 3 over 2 negative. So that's this point right here, and that is 5 pi over 6. So that means your answer is 5 pi over 6. That is the angle at which cosine is equal to negative square root of 3 over 2. So this is your answer. So let's do this one. Y'all did good. So where is tangent? Well, let's go to pi over 4. Pi over 4 is right here. What's the coordinate? Yep, square root of 2 over 2. And you know that tangent is always y over x. So that is square root of 2 over 2 divided by square root of 2 over 2, which is 1. So we can, this whole thing is just 1. That means we can write arc cosine of 1 is what? So you're asking, where is cosine equal to 1? That would be right here. because that point is 1, 0. So that is at 0. At the angle 0, right here, your cosine value is 1. So your answer is 0. A lot of people said 2 pi. It cannot be, although that is true, cosine does equal 0 at 2 pi. Remember, we have to remain in either the first quadrant or the second quadrant. All right, let me give you another one. Try that one. Okay, I'm just going to go over this one. Most of you guys got it already. I'm going to go, normally pi over 4 is here, but it tells me to go negative pi over 4. That's here. The coordinate is square root of 2 over 2 and negative square root of 2 over 2. So tangent, you divide these two and you get negative 1. So this whole thing is negative 1. So I can write this as arc cosine of negative 1. And that means I'm looking for where is cosine equal to negative 1. What'd you guys say? Pi. Because right here at pi, the coordinate is negative 1 for cosine. So the answer is pi. Next problem. This one's a little more challenging. You're going to have to draw a triangle. That's your hint. Okay, so I'm going to draw a triangle. And I know that this is adjacent over the hypotenuse. So this is 4, 5. So if I do Pythagorean theorem, I get 25 minus 16, which is 9, and the square root of 9 is 3. Okay. So if I want the arc sign, this also means what angle would give you 4/5? Well, you have your theta here. So that's your 4/5 right there. So sine would be opposite over adjacent, 3/5. So your answer is 3/5.